Hello, welcome to Maths is Not a Mystery, and today we're going to be looking at Pythagoras problems in 3D. 3D Pythagoras problems are exactly the same as 2D Pythagoras problems, except that you've got another stage to go through before you can find all the numbers that you need. So the examples drawn out here in front of you, there's a cuboid and there is a line running through that cuboid that runs from front to back and top to bottom. So it's a diagonal in two separate directions. And we're wanting to find the length of that line. Now, when you're faced with a problem like this, you need to give yourself as much information as you possibly can. So the first thing I'm going to do is I'm going to label every vertex, every corner, with a name: A, B, C, D, E, F, G, H, so that we know what we're talking about. We can't create any new measurements. We've only got those three measurements available to us. And at the moment, we can't use Pythagoras to find that long line there, because Pythagoras only works if you know two of your other measurements. Now, on this particular situation, we can see that there's a 7 centimetre line there, which we do know. We've got this line that we don't know. And then to make that into a triangle so that we can use Pythagoras, we would have to actually create a new line that goes along here. But we still don't know the length of that line. So what we've got to do is we've got to use what's available to us to find out how all of the lines measure up. We've created a triangle FGH here. Triangle FGH is the triangle that operates on the base of this. And we can use triangle FGH to find the first missing number. So line GH is 8 centimetres. 8 squared is 64. So that's a little bit of Pythagoras there. FH is 6 centimetres. 6 squared is 36. 64 plus 36 makes 100. Now, 100 is actually the measurement of GF squared, isn't it? We've not found the square root yet, as you would do in Pythagoras, but I'm going to tell you to not bother finding the square root at the moment, because in a minute you're going to do another Pythagoras and you're only going to have to square it again. So you might as well leave it squared for the time being. So because we've found this measurement, or because we've found something that will help us with this measurement, we can now do our second bit of Pythagoras to find the actual line that we want. Now, in our second bit, we're actually dealing with triangle BFG. I'm sure somebody would be very proud of me for choosing that. Okay, we're doing BFG as our triangle. And there we know that BF is 7 centimetres and 7 squared is 49. And we already know that GF squared is 100. So 49 plus 100 is 149. Okay. To find the actual line that we want, because this is now our magical hypotenuse, isn't it? So to find the thing that we want, we need to find the square root of 149. That's going to be 12 point something, isn't it? Because 12 12s are 144. So let's just get our calculator in here and let's just type in 149 and square root it. 12.206, so I can round that to 12.21. Square root of 149, 12.21. And that's it. We've completed it. 12.21 centimetres. Put the units in to get the full marks. Is the length of that. So that's how you do a 3D Pythagoras problem. Okay, you create a new triangle along the bottom or the top or wherever you can realistically create one in a 2D plane. That helps you create this sort of 3D triangle that's running through the centre of your shape. So I hope that's helpful. We do have a practice book available on Amazon if you want to look for that. 3D Pythagoras from Maths is Not a Mystery. Thank you for watching and we'll see you again soon. Bye bye.